How do we calculate the flow for an obese patient?
Very nice question. Obese means above than 100 kilogram patients, huh?
Yes.
Right?
Yes.
Before we talk about the overweighted patient, before we go with your question, I just want to mention about how to calculate the BMI. So the ideal BMI for the adult patient is around from like 18.5 to 24.5 kilogram per meter square. So if we talk about the overweighted, it will come in like a 25 to 29.9 kg per meter square is the overweighted. But if we go obese patients like more than 100 kilogram, it will be above than 30 kg per meter square is obese patient. So as per your question, if the patient's, for example, weight is like 125 kilogram, so how are we going to calculate his body surface area and how are we going to calculate the calculated blood flow? This is your question. So example, your patient's like 173 centimeter and the weight is 125 kg. So if we go with the traditional methods like Adobe's method, so what we are doing height into weight divided by 3600 and we get under root and we get a body surface area. With the body surface area, we're going to be to calculate it with the cardiac index, and the cardiac index normally we are taking like a 2.4 to 2.8 liter per minute per meter square. So now the question is how to calculate with overweighted patients to example like a 125 or 130 kilogram patients to find out the body surface area and to find out the calculated blood flow, as we know that the obese patient having the extra fats, intravascular volume is less. So first of all, we need to calculate how to estimated weight of the patients having a weight like 125 kilograms. So what we used to do, we convert your height, the patient's height into the meter. So for example, your height is 173 centimeter, you are going to convert it into 101.73 meter square. So we converted the centimeter into the meter first of all. So once you convert the centimeter into meter, so the formula adjust is normally we are taking like a estimated BMI like a 28 for the overweighted patients, so or like obesity patients. So 28 kilogram per meter square. So what we are doing, so we will calculate, we multiply 28 with 28 will be like now constant, okay, because we taken the 28 the BMI estimated. So 28 times your height into meter squares. For example, your patient height is 173 centimeters, so it will convert into 1.73 into meter square. So once you're going to multiply 1.73 into meters, so it will become like a 2.99, so almost like a 3. So 28 multiplied by 3, so you will get a calculated estimated the weight of the patient. So for in this example, the patient is having 125 kilograms. So what we did, we take a constant of 28, multiply with the 1.73 meter squares, and by multiplying by 28 into the 1.73 meter square, we get the sum of 83. So we get an estimated weight of the patient is like 83 kilograms. So we removed all the fats of the patient. So now we'll put this 83 kilogram into our normal traditional method. So that our traditional method is like 173 centimeter. We're going to be multiplied with the weight. As now weight is, we find the weight is 83 kilogram. So by multiplying with the height into weight divided by 36, and I will give you example. For example, this patient's, now I'm going to make up two methods. One with the traditional and we'll go with the linear method. So the traditional 173 centimeter, 125 kilograms. The patient's BMI is like by calculating the BMI is like a 41.8 kg per meter. By doing the body surface area, the flow we get it like a 5.9 liter flow. but by using the linear methods, now the flow is like a 4.8 liter per minute. So by using linear method, by calculating the estimated weight of the patient. So the estimated weight of the patient, the formula for study calculating the weight, estimated weight is like we get a constant 28 kilogram per meter into the 1.73 meter square. So we converted our height into meter square. So mean a meter square, so our meter square become now 1.73. So we will multiply 28 into 1.73 and we get it the weight of 83 kg. Hope it is clear and you understand how to calculate the overweighted and obesity patients. I mean the high, the bigger size of the patients to go for the bypass surgery. So guys, the patient who is more than 100 kilograms, so use the linear calculating method of to calculate the body surface area and to calculate the blood flow of the patients. So first of all, you need to know about what is the ideal BMI of the patients. So ideal BMI of the patients like is 18.5 to 24.9 kilogram per meter square. The overweighted patient, the BMI will be in around 25 to 29.9 kilogram per meter square. But over than the obesity patients, like more than 100 kilograms patient will having the BMI is like 30 kg per meter square. Per 30 kg per meter square. In this formula, in a linear method formula, we use a constant BMIs like for the obesity patient like a 20 kg per meter square, and we calculate the estimated patient's patient's weight, and then we use the traditional method to calculate the body surface area and calculate the blood flow of the patients. Hope it is clear and understandable. If you have any queries, please you can give me comments. Don't hesitate. I will try to answer as much I can. This session is for just sharing the knowledge among the Profiel community and among the medical students, and hope you get some great information regarding how to calculate the body surface area in obesity patient. Have a nice and good day. Take care. Bye bye.